Welcome to aminacademy.com. In engineering mechanics, let us discuss about centripetal acceleration and centripetal force and centrifugal force. A centripetal acceleration, the acceleration of your body traversing a circular path. Because the velocity is a vector quantity, that is, it has both magnitude and the direction. The speed is only the magnitude. When a body travels on a circular path, its direction constantly changes and thus its velocity changes, producing an acceleration. In a circular path, a body is moving, even it's a constant speed, its direction is everywhere, it changes, so it is considered as a vector quantity. Now look at this figure. Here, before that, a body moving a circle or along a circular path with a constant velocity suffers a continuous change in its direction at every point of its motion. Though the magnitude of its speed remains the same, but its direction changes, so it's considered as a vector quantity. Since the velocity involves both magnitude as well as a direction, and the velocity of the body is continuously changing due to change in its direction. Therefore, according to Newton's law of motion, an external force must act continuously upon the body to produce a change in the direction of the moving body. Here, we will discuss further about centripetal force. Here, according to Newton's third law of motion, the force which acts opposite to the centripetal force, that is called a centrifugal force, that we will discuss later. Before that, we will do the centripetal force. Look at this figure. Here, the center O, your body is moving around a circular path. That here the point, here let it be, the point is A, this point is B at some interval of time. This radius R, here this velocity V. Here this also velocity, constant velocity. This is delta theta, point E and D. Look at here, this let or the radius of the circular path in meter and V linear velocity of the particle in meter per second, and delta T is small change in time, and delta theta small change in angular displacement. A is angular acceleration in meter per angular acceleration radian per second square. Now here your body, at some time the body is at the point A, after some time delta T the body is B. From the point A we have to draw a tangent AD, and from point B a tangent DE, both having delta theta angle. Now consider an instant when point A be the position of the particle. After the small interval of time delta T, let the position of the position change from A to B. When the body is at A, its linear velocity is V, and similarly, when the body at B, its linear velocity again V, the linear velocity is not changing, then it will be dotted to, that is BE. Now we know that, look at this, in this is a vector triangle. For this we note the points, this point O, this point A, this point B. Vector OA represents this AD, vector OB represents this AE, and AB represents DE. Now here A equal, that is the acceleration A equal change in velocity over time, change in time, that is in vector this AB over delta t, let it be 1. Since the time interval dt is considered to be very small, delta t is very small, therefore AB may be considered to be the arc AB. Here AB is considered as a arc AB because delta theta is very small. Now we'll see the relation now. Therefore AB, comparing that both figure, AB over AB is equal OA over OA. Substituting the value of AB, you know that AB equal V delta T and OA this is not capital O, small letters, and OA equal V velocity and capital OA equal to radius R. And this above equation we put that AB over V delta T equal V by R. V by R. Therefore, from this we have the relation AB over delta T equal to V squared by R. And further, therefore acceleration we have acceleration is V squared by R. Take V squared by R and substituting, then that is A equal to R omega. Therefore V square equal to R square omega square over R, which is equal omega square R. Therefore we have the relation acceleration, linear acceleration is angular speed square into radius. This is the relation between linear acceleration and the angular speed. Now we'll discuss about centripetal force further. A centripetal force, that is a force that makes a body follow a curved path. Its direction is always orthogonal to the motion of the body and towards the fixed point of the instantaneous center of curvature of the path. Isaac Newton described it as a force by which bodies are drawn or impelled or in any way tend towards a point as to a center. One common example involving centripetal force is the case in which the body moves with uniform speed along a circular path. A centripetal force is directed at right angles to the motion and also along the radius towards the center of the circular path. Next, centrifugal force. A centrifugal force is an inertial force, also called fixus, that appears to act on all objects when viewed in a rotating frame of reference. It is directed away from an axis which is parallel to the axis of rotation and passing through the coordinate system's origin. If the axis of rotation passes through the coordinate system's origin, the centrifugal force is directed radially outward from that axis. The magnitude of centrifugal force F on an object of mass m at the distance r from the origin of a frame of reference rotating with angular velocity omega is F equal to m omega square r. The concept of centrifugal force can be applied in rotating devices such as centrifuges, centrifugal pumps, centrifugal governors, and centrifugal clutches, etc. Here, these equipments is acting, that is running with that means what, it's works as a principle of centrifugal forces. That means our spindle and impeller rotate fast. That means due to centrifugal forces, the water is pulled from that sump and pumped in other places with force. We are done. Please subscribe our YouTube channel.